Good morning. Today we are going to be covering section 4.3, writing equations of parallel and perpendicular lines. So the process will be very similar, but now instead of them giving us a point and the slope, they're going to give us a point and a line that is parallel or line that's perpendicular. So let's get started. Go ahead and place your margin. So we're going to have 6 squares, 2, 4, 6. Make sure that you guys are using a ruler. For today, you guys will be needing 2 cutouts. You should have your 4.31 and 4.32. If by any chance you don't have your cutouts, then just go and copy them down, pause it, copy it down, and place a box around it, and then you'll be set to go. The title for today is 4.3, and let me make myself a little smaller. That might help. Writing equations of lines, or writing equations of parallel and perpendicular lines. And now you should have your cutout. We're going to go ahead and glue 4.31. Make sure that you get the corners all the way through. Now make sure that I always have my corners covered. Now make sure you line it up before you actually commit. And perfect. So it says parallel lines and slopes. 2 lines in the same plane that never intersect are parallel lines, and that's something that you guys learned in 7th grade. 2 distinct non-vertical lines are parallel if and only if they have the same slope. So something to think about is that 2 lines are parallel if and only if they have the same slope. And this is something that you guys will see the word if and only if. That means that 2 lines are parallel if they have the same slope. If 2 lines that have the same slope, that means that they're parallel. So whenever you see if and only if, that means that it's going to work out from one way or another. So 2 lines are parallel if they have the same slope. If 2 lines have the same slope, then we know that they're parallel. All vertical lines are parallel, correct? If you have a vertical line and you have another vertical line, that means that they all are parallel. And we can say all horizontal lines are also parallel. So let's go through example number 1. On example number 1, write the equation of a line that crosses or that passes through the point and that is -1 and -3, and is parallel to the line, and they're going to give you an equation, y equals 2x plus 1. So therefore, notice that the problems are very similar to 4.2, where they give you also a point, but instead of they give you the equation of a new line, they just give you the slope. So let's go and take some time to graph this. We are going to make a 5 by 5 graph. 2, 4, 5. Let's go and plot the point, -1, -3. And let's go and graph the line. My y-intercept is 1, and my slope is 2 over 1, so I'm going to go up 2 to the right 1, up 2 to the right 1. And I can do the opposite. 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. And I'm going to connect all the points. And that is the equation that's given to me. So therefore, I need to be able to find the equation of a line that's going to go through this point, and it must be parallel, so it should look something like this. So that is what I'm looking for. I'm looking for the equation of a new line that's going to be parallel to the old one. So remember that whenever they give you a point, and let me go and highlight, if they give you a point, that means that we're going to use the point slope form. And your equation for the point slope form, we learned last time that was y minus y1 equals m x minus x1. And now we can plug in the information that we need. We need to be able to plug in the x, the points, that'll be the x1, and that'll be the y1. So where x1 is given to us here, and y1 is given to us here. So therefore, y minus, what is the value of y1? Correct, that is -3. And I see a double negative, so therefore that becomes a positive. My slope is something that I need to find. For now, let's go and plug in our x, so minus x1. In this case, x1 is -1. And once again, I see a double negative, so therefore I want to make it into a positive. And the last thing that I need to find is my slope. Now, they tell us that the new line that we're going to come up with is going to be parallel, so that's the key word, to this line here. So whenever we are looking for a line that's parallel, the only thing that we're concerned about is the slope. So I'm going to go ahead and get rid of my y-intercept. That's not something that we're going to use for this problem. And I'm going to circle my m. So therefore, the slope for that line is 2. And because it's parallel to the new line, we are going to use exactly the same slope in here. And now we can simplify. Now, sometimes they're going to be asking you guys for the point slope form, and that will be the answer. Most of the time, we want to be able to rewrite it into slope intercept form, and it's a two-step process. What is the first step? Correct, distributive property. So therefore, the y plus 3 comes down, equals 2 times x will be 2x, 2 times 1 will be positive 2. And the last step will be to move the 3 to the right, or minus 3 on both sides, whichever you prefer. And now we have y equals, that'll give me 2x minus 1. So according to this is the equation of the line that's parallel to the equation that's given to us, and that should go through this point. So let's go and graph it. Y-intercept is -1. My slope is up 2 and over 1. Up 2 and over 1. Up 2 and over 1. And now you can see why it has to be the same slope, correct? And the opposite, 1, 2 and over 1, and bingo, we found it. So therefore, that is correct. It does cross through that specific point that they told us. And we know that it's parallel because it has the same slope. The slope for the old line was 2. The slope for the new line, it's also 2. Easy as that. Example number 2. But before we actually get to example number 2, we are going to use our other cutout. So we're going to place it right below. So just make sure that you are gluing your corners all the way through. that should line it up before you commit, and then you are set. Two lines in the same plane that intersect to form right angles are perpendicular lines. Non-vertical lines are perpendicular if and only if their slopes are negative reciprocal. So now we are looking at perpendicular lines. So in order for two lines to be perpendicular, we know that they must make a right angle. And notice that little box in there. Remember that you learned that in 7th grade. That means that that is a 90-degree angle. And two lines are perpendicular if and only if, once again, their slopes are negative reciprocal. So basically, negative is going to be the opposite. So let's write down opposite. Because if it's negative, it's going to be positive. If it's positive, it's going to be negative. And remember that word reciprocal, basically you're going to flip the fraction. Vertical lines are perpendicular to horizontal lines. So let's go through example number 2. Determine which of the lines if any are parallel or perpendicular. So therefore, they are going to be giving us 3 lines. Line number 1, A, will be y equals 2 over 3x plus 3. B, x plus 4y equals 3. And finally, they're going to give you one more, which is y equals negative 1 over 4x minus 2. And I need to be able to decide whether any of the lines are parallel or perpendicular. So how can we determine if two lines are parallel or if they're perpendicular? That is a good question. So in order to determine whether two lines are parallel or perpendicular, we need to be able to find the slope. So let's go and find the slope for the first line. What is the slope for the first line? Correct. Remember that this is not going to matter whenever they ask us for parallel or perpendicular. The only thing that matters is the slope. And the slope for the second one, so let's write down m equals to 2 over 3. Let's go and find the slope for the last one. I'm going to get rid of this number, and my slope will be negative 1 over 4. And now I need to be able to find the slope for this line. So who can tell me, how can I find the slope for this line? Correct. You need to be able to solve for y. You need to leave the y by itself in order to find the slope. So therefore, to leave the y by itself, I'm moving that x to the right and becomes a negative. So therefore, that gives me 4y equals, that becomes a negative x plus 3. In one last step, divide by 4. I'm going to divide by 4, divide by 4, divide by 4. My 4 cancels, so therefore I have y equals negative 1 over 4 x plus 3 over 4. Remember that whenever we're looking to see if they're parallel or perpendicular, this won't matter. So the only thing that we're looking for is the slope. So therefore my slope is negative 1, 4. So therefore, to decide whether we have two lines that are parallel or perpendicular, we need to decide, well, these two lines are exactly the same slope. So therefore, those two lines are parallel. And this one, if this was a positive 4, therefore, we know that that'll be perpendicular, but it's not. So therefore, the only thing that we can say is that line B and C are parallel. Easy. So let's continue to example number 3. Let's go make our margin. So I'm gonna make a 6 square margin. Let me zoom out. 2, 4, 6. I'm actually gonna do 7 this time. All the way through. And example number 3. Write the equation of the line. That passes through the point 3, -1, -3, and 1, and that is perpendicular to the line y equals 1/2 x plus 3. So now they are telling us that's perpendicular. That means that the only thing that we need from this equation is the slope. So the only thing that we need is the slope. We can get rid of this number here. So therefore, the slope for this line is 1/2. And we know that's perpendicular. So what is going to be the slope for the new line? So for the new line, we have to do two things. It's going to be the negative reciprocal or the opposite reciprocal. So therefore, right now, this is a positive. So my new line will be a negative. And now I have to take the reciprocal. Therefore, the reciprocal of 1/2 will be 2/1. And I actually just need to be able to have a whole, I don't need the 1. -2 divided by 1 is -2. And that is what I will be using. So let's go and write down the equation. They're giving us a point. If they're giving us a point, we have to use the y minus y1 equals mx minus x1. Well, I'm applying the y1, I'm applying the slope that we just found, and I'm applying the x1 as well. And now let's plug it in. Y minus, what's y1? 1 equals my slope, which we found to be -2. Then we have x minus, what's x1? -3. And you notice that we have a double negative, so therefore it's going to become a positive. And that's what I'll be doing right away, so I don't forget. And now that is the point slope form of the equation that we're looking for. But most of the time, we do need to be able to rewrite it in slope intercept form. So two-step process. What's the first step? Correct. Distribute property. So I'm going to distribute the -2. Y minus 1. -2 times x is -2x. -2 times +3 will give me a -6. Last, I'm going to move my -1 to the right, or you can do +1 on both sides, whichever you prefer. And that gives me y equals -2x minus 5. And that is the equation that we're looking for. If I make a quick sketch, me press it in here. My old line was a positive 3, and my slope was up 1 to the right 2, up 1 to the right 2, or the opposite. And now, notice that I need the perpendicular line that's going to go through the line through point -3 and +1. And now I'm going to graph my new line. My y-intercept is -5. My slope is down 2 and over 1, or the opposite, 2 and over 1. 2 and over 1. 2 and over 1. So now my point is -3 and up 1. And my line is, my new line is -5 and down 2 and over 1. And I can do the opposite, 2 and over 1, 2 and over 1, 2 and over 1. So bingo. It goes to that point. And now, even though you can't tell that it's perpendicular, if I place my ruler here, you notice that it's a 90-degree angle, correct? So the only way that we know that it's a perpendicular line is by comparing the slopes. That's a -2 and 1/2. Visually, it's going to be a little more challenging to determine that that is a perpendicular line. But if you place your ruler on ID, then you notice that that is a 90-degree angle. Perfect. Example number 4. We have example 4, and then example number 5, and then we'll be done. And this is the last time that we graph it. So we just graph number 1 and number 3. So we have more conceptual understanding of what's a parallel and what's a perpendicular line. So we have example number 4. Write the equation of a line that has a y-intercept of 0 and -2, and is parallel to the line y equals -3x plus 1. So now we need to be able to find the equation of a line. They tell us that it has a y-intercept of 0 and -2. And we know that's parallel to this line. Now remember that whenever they give you something that's parallel or perpendicular, we can't get rid of this number. It really doesn't help us. It might help us to be able to graph it just like we did on example number 3. But that's about it. So therefore, it's parallel. So my slope for this line is -3. So therefore, what is the slope for the new line? Correct. The slope for the new line is also -3, because parallel lines have exactly the same slope. And now, I have a question for you. Which equation should I use? Y minus y1 equals mx minus x1, or y equals mx plus b. So we have those two equations. How do you determine which equation to use? That is a good question. So therefore, to determine which equation to use, I just need to be able to see what are they giving me. They give me the y-intercept. So if they give you the y-intercept, we know that they give you the b. So I'm going to use this equation instead. It will make your life easier if you can determine that you can use, or you can realize that is the easier equation to use because they give you the y-intercept. So therefore, y equals my slope and my b. My slope is -3x, and my b is -2. And we are done. But let's say that you really didn't realize that you had to use that equation. Then if by any chance you use this equation and you plug in the information, you actually will get the same answer. So let's try it out. Y minus, the y value is -2, and I see a double negative. We can say positive. My slope is -3 because the lines are parallel. We have x minus x1, which is 0. And now we just simplified. Distribute the property once again. So we have y plus 2 equals -3 times x will be -3x. -3 times 0 is 0. Do I need the 0? No. Move the 2 to the right, we can say -2. And therefore, we have y equals -3x minus 2. So which is an easier process? The mx plus b or the point slope form? Correct. Is the point slope form. But something that you want to be able to realize is that you can only use this equation if they give you the y-intercept. If they don't give you the y-intercept, then you cannot use this equation because that's not the value of b. But in this case, they do, so we can just plug it in there. And the last example for today, example number 5. Write the equation on the line. That passes through the point. The point that they give us is -4 and 2. And it's perpendicular to the line y equals -2x plus 1. So therefore, once again, they're giving us a point. So therefore, we cannot use the mx plus b, correct? You can only use the mx plus b when they give you the y-intercept. And they tell us that the line is perpendicular. So therefore, I don't need this number. I don't need the intercept, the y-intercept for the old line. The only thing that I'm concerned about is the slope. So the slope for this line is -2. So what is the slope for the new line? Correct. The slope for the new line is going to be the opposite reciprocal from m. That's a -2, so therefore the new slope will be +2. Not +2. You have to do two things. You have to do the opposite and reciprocal. So I did the opposite, but I need to flip it. And you guys said, Diaz, how do I take the reciprocal of a number, of a whole number? Well, we're going to place it over 1. And now we can take the reciprocal. So therefore, it will be 1 over 2. That will be our new slope. So remember, to find the slope of a line that's perpendicular, you have to do two things. You have to change the negative to a positive and take the reciprocal. And now we can use our equation. So now let's go and use our equation, which is, which one can we use? Can you use this one here? No, because they only give you a point. They don't give you the y-intercept. The y-intercept always starts with 0 and then a number. So therefore, we have to use the point slope form. And that'll be y minus y1 mx minus x1. So take the time to plug it in and see what you get. Go and pause it. You got it? Excellent. So therefore, I'm plugging the y1 and the x1. And that'll be y minus y1 is 2. My slope is 1/2. Remember, the slope for the old line was -2, but it has to be the opposite reciprocal. Then we have x minus x1, which is -4. And once again, I see a double negative becomes a positive. So you want to do that right away. And now we have y minus 2, distributive property. 1/2 times x is 1/2 x. 1/2, what's 1/2 of 4? Correct, 2. Or you can place it over 1 and multiply. 1 times 4 is 4. 2 times 1 is 2. And 4 divided by 2 is 2. Or you can just say 1/2 of 4 is just 2. So therefore we have y minus 2, 1/2 x plus 2. And one last step is to be able to move my -2 to the right. We can say positive 2. So therefore the equation that we're looking for is 1/2 x plus 4. So these are the notes for today. Have a great day and email me if you have any questions.